Alrighty, now I would like to introduce our final speaker of the day. Victor Kam is a technical artist primarily focused on modeling, sculpting, and texturing. He's worked at studios such as EA, United Front Games, and Blackbird Interactive, having done everything from environments to vehicles, weapons, and characters. In this final talk of the day, we'll explore how to use Unity ArtEngine to quickly create and manipulate materials to make your texture workflows in film and animation 10 times faster. So if you're ready, Victor, please take it away.
Thank you so much, Drew. So just a bit about myself. My name is Victor Kam. I've worked in the games industry for about 15 years, primarily as a model and texture artist. I've done anything from hard surface spaceships in the intergalactic space worlds to sculpting mechs inside of ZBrush and doing renders inside of Keyshot. I also, in my spare time, just do cool models of things that I like when I see in movies, to also military tanks as well too. I also do a lot of stylized art in my free time as well, and things like this with very Miyazaki inspired. So what we want to talk about today is really doesn't really matter what type of style you're working on, whether you're doing realistic or stylized artwork. Materials are a key part of building a believable prop, asset, or environment. And the reason why that is because just naturally your brain is hardwired to see how light interacts with the surface. And what defines that in a 3D digital medium is the material definitions. So this is where ArtEngine comes into play. So what is ArtEngine? So ArtEngine is a standalone application which focuses on material authoring. So right now the focus is creating tileable materials. We will be putting bitmaps into ArtEngine and then doing some type of manipulation with it, and then exporting that out to our game engine. So in essence, it's essentially an image processing tool. The cool thing about it is that it is backed by artificial intelligence. So we do have a large research team that's injecting AI into it every single day. So things are always improving and getting faster to help us build the content that we need for our digital mediums. So the general workflow for ArtEngine is you complete your model, whether that be in Maya or Blender, you do the unwrap, and then you bring your models into ArtEngine for building your surfacing. And then of course, once everything is put together in the render app of your choice, you kind of have the nice lighting, all the effects, you get the cool final product that you see here. Now, when you're creating materials, if you're not really familiar with how to build them from scratch, it can be quite daunting. So ArtEngine utilizes something called the example-based workflow. And what this means is it really excels when you put input data into ArtEngine, and then you do some type of manipulation with it, and then you bring that to an export to your DCC app. Now, what is the input data that you can actually use, right? You can go as simple as putting a single image. So these are just some images that I found off of Google and some from my iPhone. You can put these directly into ArtEngine and create a full material out of that. If you have more of a rig and some more space in your where you're living, you can build a photometry rig. And so this is a lot of our fabric clients will do this, where they will take multi-angle detectors. So they have 8 samples with different lighting directions, and then we composite that inside of ArtEngine to build a full material. So a lot of textiles clients will do this. My favorite one that I usually do for my work is photogrammetry. So what I will do generally is 3D reconstruct a surface, taking hundreds of photos, and then pushing this through ArtEngine and really quickly generating a fully tileable and usable material for my game engine. Also, if you have purchased content or if you've inherited some cool stuff from Ben, thank you so much. We can also take existing content and start to manipulate it with our AI tools to cater the specific needs of our project. So AI, why do we use AI, right? Like, why is this something that's kind of cool? Well, obviously, our smart devices are getting powered by AI. Social media is prevalent in social media. We're starting to see AI finally come to content creation. The demand of this content from users now, it's always exploding with the new technologies coming down. So doing everything by hand takes quite a long time, which is why we're injecting AI into material creation. This is where we come up with something called AI-assisted artistry. So inside of ArtEngine, if you're already familiar with using Photoshop or any other type of image processing software, ArtEngine already has the familiar nodes that you're going to see, like blends, levels, blur, and transform. So you're going to feel pretty comfortable in there. The ones that are AI powered that I'm going to show today are something called seam removal, mutation, and something called style transfer. So these are my 3 favorite ones that I use quite a bit. So enough of me really just kind of talking about it. I'm going to jump right into ArtEngine. We'll do a live demo to kind of show you what I normally would do inside of ArtEngine. So this is the UI. Just really quickly in the top left, this blank area here is going to be my 2D window. So it's going to be the bitmaps I've been working with. In my right-hand side here is going to be my 3D window where I'm going to be able to preview the material with all the lighting attached to it. And then just down the bottom here is going to be my working window. So the first workflow that I'm going to show you is using scan data. So I see someone in the chat saying capturing reality height. Yes, that is true. So this is a scan that I did of some gravel that was nearby. Now, the problem when you bring any type of real world material into a game environment or any type of rendering environment is that you're going to get these seams along borders here. So maybe a little bit hard to see in the color map, but if I go straight to the normal map, you see this really, really harsh seam over here. Now, to fix this, traditionally, you'll probably have to go and do some type of feathering magic or do a bunch of clone stamping. I really don't want to do that. I don't want to spend my time doing that. So inside of ArtEngine, we have a node called the seam removal node. And what this will do is, I'm just going to execute this. It's going to utilize AI and analyze that blue border and actually break down the image into smaller chunks and then reassemble itself to minimize the energy differences between the pixels. And what that effectively is going to do is create a seamless tile of this full material. So we're going to let that process a little bit. So ArtEngine is reliant on your GPU. So the more powerful GPU you have, the faster things are going to run, essentially. So we'll let that process. And so obviously, like, this is a full material that I'm processing. So there we go. So we have a full tileable material now. If I can look at the before and after, if I look at the normal map, you'll see this more evident. So this was the before, and then the AI has recomputed it to a fully seamless tile. This is really nice. So for people who are using real world images to build materials, this is a complete lifesaver. Normally, I would just put in a full material here, hit the button, and I'm almost good to go. But there's a couple other problems with this scan data over here. So the first thing is, I don't really know how large this was actually captured as. I don't have like a ruler. I didn't actually have a ruler with me or a measuring stick to measure the surface area. So what I can do is instead, I can use something called the mutation. And I did leave my gray card in here. I did have that with me on hand. And what I'm going to do now actually is use that as scale reference. So I'm going to use something called the world scale tool, and I'm going to turn on my tape measure. And that's going to give me a little tape measure widget over here. And I'm just going to drag and drop that over the gray card like so. And what I'm going to do with this is, because I know that my gray card is roughly around 10 centimeters, I'm just going to put in 10 into the tape length. And this is actually going to give me the real world units of what this is scaled off of, based off the relative scale of that gray card. So this is giving me 175 centimeters. That was the actual scan data. But for the textile density that I'm using in my project, let's just say, for example, I want to do a 250 centimeter surface with a 2K texture. So when you're working with textile density, whether you're in a video game or doing some type of film set, textile density is very, very important because you don't want to have a really high res material next to a really low res one, right? So when you do set your textile density for your project, this is where you're going to be able to kind of like manipulate the textile density for your materials. So there we go. So that got a little bit denser. So now I know that this material I have is actually at a textile density of 2.5 meters by 2K map. Okay. So now the other problem is, well, I have this gray card over here. So that's kind of, we definitely don't want that in the final material. So instead, what I'm going to do now is I'm going to use something called the mask paint node. And what the mask paint node is there to do, is there to actually guide the AI. So I'm going to loosely paint around that section there. And then, sorry, I'm just going to put this over here. So I'm just going to paint on top of that gray card. And I'm actually going to put this into something called the ignore section. And we're going to go and just run that process again. And what that mask is going to do, it's going to tell the algorithm to ignore that section that I painted and then recompute it with the data that was left over. So essentially what we're going to get is a full material without that gray card kind of like taken away. It works very similar to the content aware fill. So that didn't work because I did the wrong order. So let me just do that. This is what happens when you do live demos. So I'm just going to push this guy back in, paint that over here. And we're going to go and recompute that. So that broke because I actually put the mask paint in the wrong section at first. So I'm just going to reorder in the node graph in that way. So, so yeah, node graphs, they can be intimidating for a lot of users, but a lot of shader editors and material softwares now utilize node graph just because of the non-destructive behavior of it. Oh, and my grade card is still there. So we're going to leave that for now. I don't know what happened. So things usually happen over Zoom because it's taking a lot of my VRAM up. So we're going to just leave that for now. But let's just say that what if we had something like Shank over here, right? Cool. So we have Shank, and I got this from Ben, Real-Time Rascals, which is really nice. And what if I want to build like another version of Shank, maybe, right? The thing is, when you get content from a library that you downloaded or you purchased, you don't usually have the source content available to use, right? So I don't have like the source data that Ben used to create this asset. So what I want to do actually is extract the material from Shank and then use it on another character. So what I'm going to do is I'm going to go back into ArtEngine. I'm going to go and bring Shank's material. We're going to switch our shader over here. So obviously, if we look at this like right offhand, we can't really use this on another character. So what I'm going to do instead, and hopefully this is going to work this time here, I'm going to go and just paint. I'm going to start to paint in areas that I actually want. And then I'm going to actually invert that. So I'm going to come up with a mask like this. And what I'm going to do with this mask actually is I'm going to tell the AI to ignore everything that's in white and keep what's in black. And then what that's going to do is, so it's going to pop this back in, and we're going to let this compute. What this will do is going to use that area that it painted and regenerate like a fully tileable version of Shank's frog skin. So let's check this out. Let that compute. So, right now I'm working with Shank's material here. This is usually utilized for like extracting moss out of extra data, extracting like dirt and stuff like that from scan data as well too. So here we go. Cool. So I got a full tileable version of Shank's material now, which I can put into any other application to maybe like paint on to another frog that I want to create possibly. And if we look through all the channels, we've brought over the roughness maps and the normal map as well, and it's completely tileable, right? So it's pretty nice. So what if I don't like kind of like these little pimples or like these little moles on Shank's skin here? So what I can do now is use something called the mutation revision. And this one takes a lot of VRAM up as well too. So I'm going to go and just try this out. So what the mutation revision will do, it's going to let me spot heal certain sections. So maybe I'm not too happy with like how many of these little moles are over here. I'm just going to hit execute. And that's going to recompute that specific region like this. And what I normally will do with this tool is when I do scan data, I zoom back. If I start to see a lot of tiling, I would actually go and use this tool to patch heal it to kind of break some of that tiling up, right? Which is pretty cool. So now we have this like pretty slimy looking material here that we can use on another frog, which is pretty neat. And the other thing that I want to do also is I want to create another shirt for Shank as well. So I'm going to pull in another set of data here. I'm just going to change this to a cloth ball so we can see what's going on. So this data set here was captured with photometry. Okay, so we took 8 different images of this particular material with 8 different lighting angles. It was processed through a multi-angle detector, which gave me the colored map and also the normal map. Now, the only problem with this is due to my capture size, it's not square, right? So it's not like a usable, it's not really a friendly texture size that I can use in a real-time application. So this one's like 1000 by 1800 or so. The other thing also, that's not tiling too, right? So we're gonna have this thing over here. Okay. So if I were to do this by hand again, I'd probably have to go to Photoshop, try to square it out, and then kind of like redo all the stitching, which I definitely don't want to be able to do that. So instead, I'm going to use something called the mutation structure. Okay, we're going to set our output dimensions to 2K. We can always do 4 or anything higher than that. we're going to use 2K. And I'm going to go down to the pattern map section here. And what I'm going to do with this is actually, I'm going to select an area that I think is going to repeat. So for this type of pattern, it's actually pretty straightforward. So I'm going to choose this little chunk over here, and I'm just going to hit patch detection. So what this will do is going to take the region that I picked, and it's going to do pattern matching through its analysis. So through that selection, it actually picked out those patterns that I want. I can always kind of like manipulate how many patterns that I want to use for my final material. I'm just going to hit execute. And then this will regenerate the full material in a 2K map, a power of 2 image, with those samples that it picked out. And then we should have more usable map. So now it's 2K, 2K by 2K. And then we have a fully tableau map, and we have the normal map as well too. So now I have a pretty cool extra little shirt that I can use on Shank. And I just want to double check that it's tiling correctly. So that's looking pretty cool. So a lot of our fabric clients will use this. So the pattern recognition is really, really helpful because they will do a lot of scans for the fabric industry. And then they will use the pattern recognition to essentially create a full tile for being able to use this inside of Unity. Cool. So, we've been talking about Unity, all morning. So how does this actually integrate inside of Unity? So for those of you who have actually tried to bring a material over to Unity, you kind of have to make that mask map. You have to drag and drop it in. You got to set parameters for the normal map, and then you have to manually hook it up, and then making sure everything works really quickly. So what we're going to do is let's go back to Shank's frog skin. Oh man, look at that. That's looking pretty slimy. So I think this is gonna be a fun one over here. I do believe some people were talking, yelling at Shank. So you guys might be happy that I did this to the skin. So we're gonna take this material over here, and we're gonna use something called the export to Unity node. So I'm just gonna grab this. And what I'm gonna do with this node is I'm going to export directly into my Unity project. I'm just gonna give it a name. So I'm gonna name this frog skin. And I'm just going to hit export. So while this is doing its export, it's going to pack all the maps and create that little mask map that you need for Unity to run. And as this is actually going into Unity, I'm just going to drop back in. We're going to get a pop-up. So this is from the Unity plugin that we have. So the ArtEngine Unity plugin. So just make sure that's installed. This will actually detect the export, and I'm going to choose which render pipeline that I want. So I'm going to use HDRP, and I hit OK. And then what that's going to do, it's also going to generate the full material for you, right? And it's going to reassign all those maps. So here's the mask map that we did. So this is a really, really quick workflow for you to work with materials inside of ArtEngine, hit the export button, and then Unity will have a full realized material out of it. And now what I can do with this material, of course, I can put it onto maybe Sydney over here. That's looking a little bit crazy, so we're not going to do that to poor Sydney here. This is the fabric material that I already generated earlier on, so we have a new shirt for Shank, which is pretty cool. So we looked at these two characters over here. What about the stuff in the background, right? What can we do with the stuff that's showing up over here? So we have a nice bus, we have some cool houses, and a backdrop and a little tree. So when you're working in a smaller team where you don't really have the budget for a lot of concept artists or traditional painters, maybe I want to try and just explore some different looks and styles with some of the assets that I already have. So personally, I can work in a 3D medium, but for some reason I just can't paint and do stuff traditionally. So what if I want to do something a little bit more abstract with what's here? So what if I, want to, this is the image that I want to do. Maybe I want to do something like this, right? Maybe my art director wants to explore how the set is going to look with this particular image here. So what I can do with something called our style transfer node, this is still something that we're working on right here, but it does utilize AI to do this. So what I did was in the back end, I took the textures from the backdrops over here, and I'm synthesizing it with this one here. And then we kind of get this little cool thing like this. So now I've already really kind of just pre-visualized, a completely different look by just using two images together, right? So, maybe this is not something that I want. Maybe I want something a little bit more gloomy. Maybe I can do something like this. You know, I love Gothic stuff. I just watched Lord of the Rings again, so this was kind of reminding me of that. And we can just try that out. And ooh, that looks a little bit too gloomy for today. So maybe that's not the best for today's presentation. So we're gonna kind of just go and do something a little bit more watercolory like this. And we kind of come up with something like this. So this looks a little bit more in line with the mood today. So super cool and super fun, and even Shanks got a bit of a treatment there as well too. So yeah, so this is the style transfer node, which is pretty fun. Let's see what we got. There's a bunch of other nodes inside of ArtEngine that we just don't have time to kind of go through. But we also have our upres node, which was actually shown off at the latest GDC keynote. So this is a lot of training data within the upres. It's very comparable to the NVIDIA upresing that's available currently. Insomniac Games did a talk on the upres node as well, which is really cool. We also have content aware fill, which we're pretty familiar with when coming from Photoshop. JPEG artifact removal is also an AI-based node. Pattern unwarp for fabric industry. Again, it's going to utilize AI to unwarp fabrics, so you can kind of get more of a flat texture. Batching is usually used for, you know, large-scale productions where you just have to do a ton of material work. Batching is something that I wish I had in my previous studios, because, you know, doing things like frog skin and playing with Sydney and Shanks is always fun, but there is always that kind of work inside material production where you have to kind of level out thousands and thousands of materials. This is where batching nodes come in. And there's also just like a ton more stuff, right? So feel free to go and check out trial version. I do believe there's a huge discount right now for a GDC promo for ArtEngine, so definitely check that out. And thank you so much. That was ArtEngine. Back to you, Drew.
All right, thank you so much, Victor. That was fantastic. Seeing a lot of blown minds in the chat right now.